Hi everyone, my name is Nick Macchio, and today I will be presenting my project on predicting the S&P 500's percent change for April of 2025 for my data mining and for competitive advantage class. The goal of this was to forecast the percent change in the S&P 500 for April of 2025 using a time series model. The historical data I chose to use was from March of 2021 to March of 2025. We needed a total of 48 basis points, and I also didn't want any effect from COVID, which is March of 2020, as we all know. So I took it a full year later from March of 2021 all the way up till March of 2025. Little background, forecasting the financial markets is always hard. I think everybody, including everybody on Wall Street, is always trying to forecast the market and predict what's going to happen. But in this case, the time series analysis gives us a nice structured way of modeling the past behavior and hopefully to be able to predict some future trends that go along with it. Problem, I wanted to find the best model to predict the percent change for April of 2025. The models I compared were the naive, ATS, and ARIMA model. The variables I focused on were the volatility index, volumes, interest rate, CPI, and inflation. The reason I chose those mainly because the S&P 500 can be traded, but it's more of a conglomerate of stocks. It is 500 stocks to be exact, so I believe that more, I guess, the volatility index or interest rates, they affect the S&P 500 more than it might affect a singular stock. And then for my training and test data, it took 45 months of training with the 4 months of testing data. My data from the S&P came from Yahoo Finance, while the CPI and the inflation came from tradingeconomics.com. I cleaned this manually and put it in a CSV file, and that way I was able to import it into R so I could run some analysis on this. Here is my correlation heat map that helped me see the variables and the relationships they have. The CPI, volatility index, and the interest rates relate not just to each other, but specifically to the percent change of the S&P 500. For example, the CPI and the interest rates had a strong positive correlation, while the volatility index and S&P were negatively related, which of course makes sense, but this does match typical market behavior. Then this is the data exploratory, the monthly change plot, monthly percent change plot. This isn't going to be like a normal stock price plot where it's just up and to the right. Everything is always growing because this is a percent change. So each month it, I guess, technically does reset, but it does help us visualize the patterns and the trends and I guess the volatility that happened over time in the last 4 years for this analysis project. Before building any of the time series, we had to check to see if this data was stationary or not. Meaning basically that the mean and the variance stay consistent over time. I ran the augmented Dickey-Fuller test with the p-value of 0.04474, which is below the threshold of 0.05, and I was able to reject the null hypothesis to confirm that the series was stationary and it was appropriate to use it for forecasting. Some of the other things I did was to move some of the NA values. The first month had an NA value because you couldn't get a percent change from the month prior. I excluded April 2025, any data from April 2025 because we were projecting April 2025. And the recording of this, it is obviously late April when this is due. So hopefully we can maybe by the end of this month see how close the projection was to the actual outcome of the month of April in the percent change. But that's what I did, and then I formatted the data into time series. Tested 3 models, the naive model for a simple baseline, the ETS to capture seasonality, and the ARIMA for randomness and trends. Here are some visualizations. The first two, the naive versus the actual plot, and the ETS versus the actual plot. As you can see, the naive didn't pick up much in terms of the patterns, but the ETS did a little bit better of a job. But personally, my favorite was the ARIMA plot, and this model showed the tightest fit compared to the S&P 500's changes. Not only did it track better than the naive and ETS, but it also maintained a much tighter confidence around the forecasts, meaning it was both accurate and stable across the different periods of time. Here is what we looked at when we did the training and the test data. ARIMA and the ETS both outperformed the naive model in terms of RMSE and MAE. While ETS was close, the ARIMA edged it out, particularly looking at the stability and the diagnostics. This just more so enforced that ARIMA was going to be the most consistent model that I was going to be able to use for the training and then my test data to predict the percent change of April in 2025. To avoid overfitting, I checked the ARIMA model's residuals pretty closely. Didn't want there to be any noise or anything like that. And there wasn't any obvious patterns, which was good. I did then the little Jung box test, and it returned a high p-value of 0.92, which meaning the residuals were effectively random, and that this confirmed that the ARIMA model that I used to capture the real data without being too tightly fit to the historical data. Here is the result of the Jing box test. As you can see, the p-value. Ultimately, ARIMA did handle the randomness better, and it passed all the tests, so that's the one that I chose to use for my April of 2025 forecast. Unfortunately, I think, at least for me, not too interesting, but the final forecast did predict a percent change of 0 for April of 2025. It did have an 80% confidence interval that it would be between negative 5.61% and positive 5.61%, and a 95% confidence interval it would be between negative 8.58% and positive 8.58%. Obviously, this isn't the most groundbreaking thing in the world, but this is what the model showed. The final plot here shows the forecast for April of 2025 going up a little bit, but it does have a minimum change overall. The confidence intervals do reflect the uncertainty because in the stock market it is pretty uncertain. Anything can really happen. Any kind of large events can skew the market one way or another, especially for the S&P 500, which is one of the most well-known, I guess, indexes in the world. Overall, I did like the ARIMA. It did provide, in my eyes, the most reliable model for this project. It did balance the bias and the variance better than the others. It, in my eyes, did produce the most accurate predictions, passed all the tests, and while it's almost impossible to predict something perfectly because of because of some type of a market shock or some type of outside influence, this is relatively normal because of just outside noise that can influence the market on a day-to-day basis. Throughout a longer period of time, if there are good numbers and good statistics, you probably will see your stock growing, but in the short term or in terms of month by month, it's harder to notice a consistent growth if something wild or something out of the ordinary happens. Like, for example, if COVID happened, or if the tariffs or some other international something took place, it's going to have a pretty large effect on the stock price. Some of the challenges were collecting and the cleaning of the data because they came from two separate sources, so I had to combine them so I could use them within my analysis. And of course, any kind of, like I had mentioned just now, any kind of external shocks or outside noise that can affect the markets or the economy, you can't really price those into this model, especially if they happen during the month of April when all of my data was prior to the month of April. Some of the lessons I learned that validating models properly is crucial, and that real-world forecasting does require flexibility because some things can change pretty quickly. Like I said before, we are towards the end of the month of April, so I will be interested to see when the month is up to see how close my analysis was in terms of the percent change, if it was within the confidence intervals, and go from there. this was my time spent. I spent about 24 hours on this in total. Well, just the analysis part, I should say, spent 24 hours, a little bit more in terms of the the reading about the S&P and learning about it, because I thought I was familiar with it, but in reality there was a lot that I did not know about it. Again, here are my sources: Yahoo Finance and tradingeconomics.com, and thank you very much for watching.